We're talking about 7D, we're talking about the tangent function. We've talked about in both graphs of sine and cos. We've seen those wavelengths. Tan is very different because it doesn't have that sort of same wavelength. It's still a periodic phenomenon. This is what it's going to look like, and it's just going to repeat itself like that in the horizontal direction. Now, why does it go like that? Why do we have these, what are the dotted lines? Asymptotes. Why does it have these asymptotes? Well, tan is sine on cos, isn't it? And if we think about our unit circle, okay, at this point here, that's an angle of pi on 2, 90 degrees. And at this point, you can see the x value is 0 and the y value is 1. And so then sine divided by cos is 1 divided by 0, which is undefined. We can't do that, and so we have an asymptote at pi on 2. Okay? Negative pi on 2 would mean we're going this way, 90 degrees. So that would be negative pi on 2. This point here, x value is 0, sine of minus 1. Okay? And so again, it would be minus 1 divided by 0. And so again, we have an asymptote here. And it's just going to keep repeating itself. What we see at an asymptote, right, is that it's approaching positive infinity there. Okay. What else to say about the tangent function? It has a wavelength of pi. Okay, you can see that distance is pi on 2, and that distance is pi on 2, and if you go pi on 2 plus pi on 2, you've got pi. You've got one lot of pi. And so that means the wavelength is going to be pi on b, right? Now we saw for sine and cos, it was 2 pi on b. For tan, because it has a wavelength of pi, the wavelength given any specific value of b, like we'll investigate in a moment, will be pi divided by b. So that's it. And again, this is one where we're going to really use our calculator to support us. So firstly, it asks us to graph this function, tan of x plus pi on 2. All of A, B, C, and D are going to have those same effects. Like, if this is our general tan function, okay, A is the amplitude, right, for a sine and cos function, and that's stretching it like this. So that's still going to have the same effect. You can either stretch it or bring it, squish it in, bring it all a bit closer. Okay, B is horizontal compressions and dilations. Okay, so we can squish it in this way or squish it out that way or stretch it out that way by changing the value of B. And then C and D, C is going to just move the whole thing over this way or that way, and D is going to move the whole thing up or down. Okay, so all of them all still have the same effect. So let's sketch tan of x plus pi on 2, and you could just straight away open up your calculator and graph it. And we are asked for minus pi less than x less than pi. So that means we've got our axes here. This is minus pi and this is positive pi. It means over that region. Now just give you one hint when you're using your calculator. Okay? When you go into V window, okay, set your scale. There's a scale option there in V window. Set it as pi on 2 or pi on 4, and what that means is every grid line then will be in terms of pi. Okay, now I'm going to describe this one. I'm going to describe how we're doing this one. We've got tan of x plus pi on 2, so that's horizontal translation, and it's plus, which means we're moving it to the left. Okay, it's moving this way, pi on 2 units. And so that means this asymptote that's normally at pi on 2 is going to be shoved over another pi on 2 this way. Okay, so if we've gone from negative pi on 2, we're going another pi on 2 over, that's going to be at pi. We have our first asymptote here at pi. Then we have this root, which is normally at 0, is going to be shoved over pi on 2 units. So now rather than being at 0, it's going to be at pi on 2 there. And then the other asymptote, which is normally at pi on 2, is shoved this way pi on 2 units, so that's going to be at 0. We have an asymptote on the y-axis. And so the graph is going to look like that, okay, for the first part. And then for the second part, it's going to repeat itself. So we've got asymptote there. We have the next root is going to be at pi on 2 again. Excuse me, that's a full line. And then another asymptote at pi, okay? So it just keeps repeating itself in that horizontal direction. When you're graphing these, like so you can see our constraints for x minus pi to pi. For y, you might want to crank it out to like minus 20 and positive 20, so you can really see that stretch, or minus 10 and positive 10. Excellent. Okay, find the period of tan 5x. Okay, so the period, the wavelength, that means how long is it for one wave. Okay, what's that distance? And the formula is pi divided by b for the tangent function. So that's going to be pi on 5. Now remember, I keep saying this, pi is just a number. It's like 3.14, okay? So like roughly, very roughly speaking, that's 3 divided by 5, which is 0.6. Okay, so very roughly, this has a wavelength of 0.6. And so what that means is for one of those, rather than being 3.14 units, it's now 0.6 units. You've squished it right in. Okay? Or, just like with sine and cos, 5 wavelengths in pi units. Alright? That's all. So let's have a go at it. Use your calculator to help you out. This is 7d, the tangent.